I've got a lot to cover, so I'm going to get started. Good afternoon. I'm Marley Gray. I'm an architect on the Azure blockchain engineering team, and I'm going to walk you through about 3 weeks of content in about 49 minutes, and then we'll slow it down a little bit. Real quick overview, 3 major sections here. First, quick primer for those of you that haven't done much about blockchain and really understand it. Real quick level set, just in case somebody needs to catch up. Then we'll talk about core blockchain infrastructure and what we're doing there. And then I want to spend the bulk of my time on the application development platform, which is fairly new. So, quick blockchain primer. There are probably 4 kinds of people in the room, and it's really hard to get people to respond to these things. So the first one is, if you heard of blockchain, don't really understand it, kind of raise your hand. Anybody kind of new, heard about it? Heard of Bitcoin? Anybody have Bitcoin? Anybody sold all their Bitcoin and lost a bunch of money after somebody told them to sell it when they shouldn't have, done so? That's happened to me 3 times. So, all right. So then there's, you've read a bunch of articles. There's a whole bunch of hype. You've done some dabbling here and there, but not much. And the third is you spent some time. If you've done like 2 and 3, sometimes it's a blurry line. You spent some time. How have you played with any sort of blockchain? Anyone? Okay. Those are painful lessons. I'll talk about how painful this experience can be, and I'll show you some of the things there. And then anybody in this category, certified crypto anarchist? I didn't expect you guys to actually be here. Anyway, you'll all get something out of this talk. What we're going to really talk about is sort of, how to approach blockchain, how you can start to approach it from a business perspective, and as a developer, target this market. So what's the big deal? Blockchain, if you look underneath the covers, there's nothing really new there. It's tried and true existing technology. The crypto's been around forever. Distributed databases and networks have been around forever. The peer-to-peer discovery and network protocols have been around forever. It's just the combination of this largely well-understood technology that comes together to really make people think differently about what the possibilities are in all industries. It started in financial services, but it has really spread the spectrum across all those ecosystems. The initial simple design was based on Bitcoin, the cryptocurrency, so blockchain, its first implementation, if you will, still live and running. It's proved itself time and again. I told you I sold sold my Bitcoin 3 times, thinking, that's it, it's never going to go up anymore. I've actually lost initial Bitcoin because I lost the private key. I didn't think anything of it at the time. I actually just deleted the computer I mined it on. Anyway, that's probably worth $100 million or something ridiculous now. So it wasn't until the introduction of smart contracts that blockchain really started picking up steam. And it became a big deal. And usually the excitement came out of the lines of business. It wasn't from the technology people, because people looked at it as, that's just PKI. That's just distributed databases. Big deal. But the business people really got the bug, because it really fundamentally changes the way enterprises and enterprise organizations, companies, and people selling to companies think about systems. So there's 4 basic pillars. Every time I try to describe blockchain, I try to boil it down to 4 things that you can look at anything and say, hey, does this make sense here? So the first is, the sentence is cryptographically authentic shared distributed ledger. So that's a mouthful. So ledger is at the very end. So ledger is very important. I spent a good portion of my college career, about 15 minutes as a freshman, taking accounting 101. I promptly dropped it after I figured out it wasn't for me. But one of the things I did learn in that 15 minutes was that in a ledger, you can't erase. If you write in a ledger, you can't erase, you can't scratch through. You have to actually post a corrective transaction, which I've actually had to do in my professional career several times with expense reports. Those are another story altogether. But, so a ledger is very important. We'll get back to the ledger, but that's sort of the key pillar. The first piece is cryptographically authentic. This is using standard off-the-shelf cryptography, public-private key signatures to create digital signatures are essentially used everywhere in this, but it creates a shared truth that people can agree on. So using this crypto, everybody can agree that if you use these cryptographic algorithms, digital signatures can't be fraudulent. It's infeasible to crack. We can't say impossible. Cryptographers have thrown sharp objects at me for saying that. But it's cryptographically authentic. That is one of the key pieces to allow it to be shared. So the value there is once people agree that this can represent the truth, then people can agree to share that truth, which is seems sort of basic, but actually from an enterprise standpoint, it is pretty dramatic. And then distributed. So when you look at the cryptographically authentic, shared, and distributed pieces, those three things allow separate organizations to come together to have a single logical ledger to represent transactions between them and other people inside of an ecosystem. So you have one version of the truth that can't be fudged, can't be gone back and cook the books. You can't correct mistakes. It means you can't, and also someone else participating in the network can't either. So it creates this shared sort of value chain, and that's where Bitcoin came in as a cryptocurrency, because currencies and money is all about trust. Pull out your dollar bills or your currency and you'll see trust and somewhere written on there. We won't get into the why money is magic thing, but that's what blockchain is. So then let's talk about the implementations. So you have two basic categories. They're public blockchains. There are going to be a handful of these. Bitcoin's the most famous. Ethereum's probably second most famous. Ethereum is what launched the implementation of smart contracts. And then you'll have a bunch of different cryptocurrencies, a whole bunch of coins being minted, people trying to arbitrage on launching a coin and then dumping a bunch of it on a market and see make pennies on the dollar, or pennies on pennies, actually. Anyway, there'll be a handful of these. These are what we call trustless blockchains, and those are the ones they try to wrap their head around this thing called proof of work. If you've heard of mining, everybody heard of mining? Anybody mining? It's similar to coal mining. Well, I'm not going to go that route either. It's sort of a waste of time because it is essentially a massive guessing game between all the computers participating in that network. To make it difficult, it's essentially a behavioral modification protocol to make bad people do good things. How do you incent people to maintain this ledger and its integrity? That's what proof of work is, mining. It's very it actually works very well, but it's slow. So like transactions per second in the enterprise space, Bitcoin graciously, people will give it 7 transactions per second. In all honesty, it's probably like half of that. But if you go to any enterprise and say, oh yeah, we can get 3.5 transactions per second, there's the door over there, and you'll get thrown out of it. So private blockchains, well, these are the ones that most people are very interested in, particularly in the enterprise. So these are sort of semi-trusted networks that you can build. And because when we say they're private, they're like members only, it means we know who's on the other end. On the trustless networks, they're completely anonymous. So you don't know who's on the other end of a transaction. You know you can transact with that person because it's the blockchain keeps it fair and square. There's no way to, you don't have to worry about that aspect. On the private blockchain, these are where you have strong KYC requirements in enterprises. You probably know your customer requirements. Private blockchains are here. So there's, like Ethereum can be, that was the first sort of off-the-shelf, well, not off-the-shelf, sort of in the back of the room underneath the shelf, covered in like bunches of blankets and infested with rats. You could find Ethereum and create a private blockchain back in 2015. That has progressed a lot. We're now forming Enterprise Ethereum Alliance. There's a implementation called Quorum that actually JPMC created. That's based off Ethereum. But they're all in the same family. And then you have Hyperledger Fabric, which is IBM's. Hyperledger itself is a larger Linux Foundation project. And then we have very niche boutique blockchains like Chain is one that most people have heard of, actually very strong platform. Probably have the best tools in the business. And then Corda, which is R3, another one of our partners. R3 is this massive consortium of financial institutions. All the biggest, we call them globally systemic financial institutions, or GSIFIs, are a member of R3, and their platform is called Corda. It is a distributed ledger, aka blockchain. It's a nuance, but there's going to be those will kind of narrow down to several platforms. There are fundamental differences. We go back to say the databases, these two implementations, smart contracts we're going to spend a lot of time on are built on what we call account-based blockchains. I'll describe this to you in a minute. Bitcoin-style blockchains are what we call UTXO, or unspent transaction output databases. So it's a data scheme. Probably the best way to describe it is it allows you to make change. It's really good for currency. So if you have $1 or 1 Bitcoin and somebody's charging 0.35 Bitcoins, and all you have is that $1 bill, you can't tear off 35 cents. You spend that 350, or excuse me, spend that 1 Bitcoin, they'll get 0.35, you'll get back your 65 cents or whatever. It allows you to make change. That keeps happening over and over again the more transactions. You get this massive fragmented set of UTXOs. Whereas account-based blockchains, you can create these smart contracts, and they actually have a fixed address, which we'll talk about here in a bit. But they're completely different. You can do smart contracts on both of them, however. They're just optimized for different types of things. So let's come back to why industries are very interested in this. So the true power of what a blockchain, once you get a network effect, a blockchain is essentially useless within a single enterprise. When you get two enterprises or two individuals, it has some value. But it's when you start getting you get the hockey stick going, and the more and more members you get going on that, and the value of that network increases. Once you do that, you essentially get the point where you can do all transactions peer-to-peer and get rid of layers of intermediaries. And if you go into any industry, how many of you work with enterprises, are in an enterprise customer, are an enterprise customer, bank, a healthcare company? Okay, a lot of people. You look at any business process you probably have middlemen, intermediaries. There's friction in the system. This has the potential of flattening out those ecosystems. So peer-to-peer value exchange with almost instant settlement time. So you look at any industry, there's settlement time can be very painful. In financial services, we talk about T+3 in equities, and the swaps and a lot of derivative markets. There'd be 15-day settlement time between when a trade is closed. You actually know what the positions are on paper, but you can't get the money, and you can't take the money that you have in reserves for that to do anything with it until 15 days. It's really, really bad. So audit, if everybody goes to this one ledger, everybody's took accounting. So a lot of these big accounting firms are looking at what it's going to do to their audit businesses, because this makes audit a lot of times, and within one enterprise, is just them going in between different companies and comparing ledgers, making sure everyone's ledger matches up. And you don't have to do that anymore. We have one ledger, potentially. Distributed economics, where we have shared risk, cost, essentially everything. We share incentives and costs. And identity is in there. Everybody talks about identity. I'm not going to spend too much time. We have a whole group focused on that. But basically, enterprises fall into two buckets. You have fear and you have greed. Fear are those organizations that have a significant amount of business in the middle. Maybe they're a clearinghouse. They're matching customers and buyers. You might be in a long supply chain that you're really just matching things, everything from foreign exchange to cross-border payments. Those type of companies are endangered. And then greed, we have organizations that are saying, hey, this is an opportunity for me to grab businesses that I'm not currently in, that I actually consume a lot of, and I can probably do it better. So there's a lot of things that are in there. So let's talk about core blockchain infrastructure. So I'll go through this and see how many people this has actually happened to, because this is what's the most common when people come to us, is the CXO went to some business conference like this, except they're dressed a lot better than we are. Probably have better food too, but anyway. So he comes back and he says, hey, we need a blockchain. We need it now. There's that Dilbert cartoon, I don't know if you've seen it. We need a blockchain. We should get the one that's in purple because it has more RAM. But they come and say, hey, let's do blockchain. And you're like, okay, how do I do that? This is hard. So back in the summer of 2015, I was actually in New York. August 2015, Ethereum launched. And I said, I'm gonna learn how to do private blockchains because I know my customers are gonna want to do this. So I took 2 days on a weekend, without any sleep, essentially. I slept at the office. And I just wanted to get 2 nodes in a private blockchain connected to each other to get it to work, all right? So I install my trusty version of Ubuntu. I clone the source repos. I download the compilers and it fails. I get pissed, right? There's no documentation, very obscure libraries. So I'm like, okay, this is horrible. Finally, I get one of the nodes to compile, get the other one to compile. Start the node, and as soon as you start the nodes, they automatically want to jump onto the public network. And it starts downloading all the blocks from the public network. You're like, no, I don't want to do that on the public network. I might screw things up. If I'm going to fail, I want to fail in private. Right? I don't want to be embarrassed out there. Some crypto anarchist can make fun of me. I do that all the time anyway. So I tell you about the Bitcoin that I sold 3 times. Anyway, I think they're telling me that I'll read it for a reason. Anyway, so then I finally get the 2 nodes to come up. And then to try to get them on the same blockchain network, there was no documentation. You had to get this. I actually had to break down and go into the source code to figure out. There's these weird configurations. This is Ethereum, the first version. So you have the exact same Genesis seed, but this is weird JSON file. On the same TCP port, this network ID was extremely important, which I didn't even know was there. And then you had this peer and hash code thing. It was horrible. Anyway, I finally got so pissed, it was horrible. And I wanted to burn. I was in a high rise in New York. That's not a good idea. But eventually I got a single transaction to go across and get mined. And after 2 days, I was in tears. I was just so happy. And this is what it looked like. And who in their right mind would think that's a beautiful thing? I mean, it's horrible. But I was quite happy with it. But then I said, you know what, there's got to be a better way. So that was in August. November 9th in London, we launched Blockchain as a Service for Ethereum to get that 2-day end-to-end experience for me that's been doing this forever. To down to about 20 minutes, 15, 20 minutes in Azure. We call it the fail fast, fail cheap platform for you to be able to stand up a private blockchain so you could fail in private and not charge a fortune. You actually do it for free. $150 credit, you could do quite a bit. Only 2 versions. There was a Go and a C++ version of Ethereum, and those 2 different versions didn't really talk together very well on a private network. Public, they were fine. But anyway, we launched that and got lots of fanfare. I was kind of shocked because that was the size of the Ethereum conference. That was DevCon 1 in this really cool place in London. And anyway, we got lots of press out of that. Now, fast forward to today, the first thing was about people trying things out. We're rapidly accelerating to people actually planning for production. So we have Azure's across 38 regions around the globe. That's not 38 data centers. That's 38 regions, different to cover jurisdictional, data residency, all sorts of compliance things for enterprises. You also can do things in Azure Stack. So the blockchain stack is on Azure Stack. We have about 8 different ledgers. That's probably going to go up in the next couple of weeks. But there's a handful of very valid ones. Chain and Corda are a private company, blockchains, Ethereum/Quorum. Then you have these others, Americoin, Strato, and Parity. Then some basic dev tools. You can do full consortium deployments, not just 2 nodes. You can spin up hundreds of nodes on the same blockchain network in like 20 minutes. It's ridiculous, but it's great. And then you can do it. You can create your own consortium. Like as an enterprise, you can seed the first slice of the pie, and then have one of your partners or your competitor, or whoever's going to join that network, will just join your slice of the pie, and they can just all do this fully scripted, and you can roll out this infrastructure very quick. I'm not going to spend too much time on this. I'm going to show you what it looks like. And oh, it's going to make me do the phone authentication thing. For those of you who are curious, yes, I am using a Mac. Most blockchain devs out there, a lot of it was done in Linux, so Mac was the user-friendly version, and so I adopted the Mac, and now I can do both Mac and Windows. So it's kind of nice. So what you'll notice here, and once you sign into the portal, you'll be able to just click on a new, and there's actually a blockchain category, which is a pipe dream for me. I actually made a statement in 2015 at that launch that, hey, we'll eventually have a category in the marketplace. And you'll be able to browse these. You'll see different types of blockchain networks. And then you can just pick one of them, and I can say, if I want to do I'll just do a consortium network, and it'll walk you through step by step in a wizard, just to fill these forms out. And literally, you're going to fill these forms out. The process is the same for all these different blockchains. And you'll be spinning out a multi-node network within minutes. So it's ridiculously easy compared to the experience that I initially had. And that will continue to progress into fully managed blockchain. Blockchain as a service was an unfortunate name that I named it at the time because, well, it seemed like a good idea at the time. But it seems like it's kind of weird when you talk about distributed systems and you say it's as a service. But anyway, it is becoming a fully managed service. Now let's switch over to the development platform. So, look at what you asked for. We made it ridiculously easy to spin up these blockchain networks, but that rapidly exposed the next major hurdle. What do I do with it now? I've read all these papers about solving world hunger and getting rid of world poverty and fixing our identity problems, and fraud will be no more. What do I do with it? How do I work with this thing? So the development tools are horrible compared to what we're used to. Very immature. It's very difficult to work with. You'll see and the architecture for those of us who've been building software in the non-crypto anarchist world. This is like going back into the mid-90s as far as architecture. And then working with real-world data, if you've been doing any sort of React design patterns and working with events, that doesn't really work very well here. So how's it going to work? It's really bad. Lots of constraints here. All the code on the blockchain must be deterministic. So that means with the same input, it's always going to spit out just like a cryptographic hash, one-way hash, it's got to be deterministic, which the code on the blockchain runs on every single node. So if you have 1,000 nodes, and that one method call or function into your smart contract will run 1,000 times. Now, each of those 1,000 times will come up with the same answer if the code is deterministic, but it's still going to do it because it has to make sure everything's valid and the integrity is preserved. Now, that's for public blockchains. We'll talk about private in a minute. Your code can't fetch or call outside the blockchain because you'll break determinism, especially if it's volatile data, like market data. Even with the speed of light, if you have nodes that are all in the same data center and you say, go, somebody could be off by a couple milliseconds, the price can change. And they'll come up with different results on the same formula. So you can't do that. UTXO systems, unspent transaction, like the Bitcoin networks, their virtual machines are extremely limited. Most people were building apps with opcodes. If any of you ever had to do anything or integrate with the mainframe, back in those days, you would find these fields, position-oriented flat files, and you'd find a field It's like 2 characters, and nobody was using it. They didn't know what it was for. And you said, I'm going to build an app, and I'm going to put an A in those 2 fields. And when you see an A there, you go do this thing over there, and you change it to a B. Yeah, the good thing, that worked fine, and you started doing that. And then somebody else saw those 2 fields. Hey, nobody's using those 2 fields. I don't know, these A, B things. I'm going to put a 1 in there for this app, and it just breaks everybody. It's horrible. It's just a hack. So Ethereum came out. Ethereum, its virtual machine is Turing complete, which is great. It also sucks because you could shoot yourself in the foot very easily. There was a famous, something called the Distributed Autonomous Organization, or the DAO, that people really want to hack. I mean, they were using the platform, and they found a loop in the contract and siphoned off some $50 million. And they forked it and recovered it, but it was a big thing. Oh, and the typing is tough. Just working with the types, unsigned integer 32s and byte 32s, and everything's in hex, right, in the database. And all the addresses, that's actually an account right there. I don't know if this laser pointer is working down at the bottom. That's actually a hashed private key. So the true promise here, beyond assets, provenance, and lineage. So when blockchain first came out, Bitcoin is all about asset issuance, creating something. We call it the provenance moment. When something is recorded on a ledger, that's when it's created. And then when you transfer ownership, you sell it or you transfer it, it keeps that ledger, so it knows the path that asset has gone through. So you have the full lineage of things. So people started saying, oh, it's great for currency. Let's use it for commodities, gold. You hear a lot about, there's lots of exchanges putting gold on the blockchain, which was like, man, gold weighs a lot. How's it going to, network's not that strong. But steel pallets, commodities, because these things are just raw assets. You trade those things. But you need more. So for early marketplaces, when people were trading chickens for logs and goats for, I don't know, other stuff, when money came along, it kind of let people exchange things, but you needed more. So smart contracts essentially, now when you have the blockchain where you can do this trusted value exchange from peer to peer, we need to have futures contracts where I can make future orders or claims and be able to talk about agreements to help resolve the truth. So we move from record of the truth to contracts helping us resolve the truth. And you combine those 2 together and it gets very powerful. So smart contracts are just like any paper contracts. We have this, I picked this loan out specifically because I know some of you in this room are fans of the Ford Focus 2007. Look at that interest rate, 21.533%. I'm in. Let's go buy this car. But anyway, if you ever bought a used car, everybody fills these things out. When you fill them out, you have dynamic properties and static properties. So static properties are your signatures, interest rate, when the payment's due, if the payment's late, what is that date? And then you have dynamic variables, things that could change. So if you have a floating interest rate, that would be dynamic. And then contracts have logic. Again, if the payment's not received by this date, there's a late fee, which occurs it's payable on this date. So you have logic in the contract. So when you start netting these things out, you can create this small program, which is called a smart contract. And it's bundled and packaged into this one deployment thing called a smart contract, written in Solidity. You can also write them in something called Serpent. Most people are writing them in Solidity. But essentially, your properties, schema, right? Your ledger is the actual database itself. Once you deployed the schema, your ledger becomes your database. And your logic is just your program. And you're storing your state in the ledger. Well, the problem is you have the ledger and your logic, the database and the logic commingled together. There's no separation of concerns. So, and you can't get outside data. So you have to get these things called blockchain oracles. So if you need interest rates, you have to get an oracle to provide that to you. If you need to send a bill to a customer, you can't actually, hey, send this bill. You have to write something in the blockchain. Somebody has to watch for that field. Sound familiar? See that field? Oh, I'm going to pick that field up. I'm going to go do this thing over here. Essentially what's happening. And then, when you deploy this thing, you get this one file and you deploy it. The contract is deployed to a node and it's copied to all the other nodes. So I have all these nodes here, so it gets instantiated and deployed on every one of those. When a single message comes in, so these are passive, you send a message to the smart contract, it wakes up, it executes that transaction, and every other node does the same exact thing. So there's no scale. So if one of these machines is a 486 DX2 with 4 megabytes of RAM, whatever, your network is going to be that fast, okay, until you get settlement finality. So there's no scale. Versioning is difficult because if you have a bug in your logic that you want to fix, you can't version it independently from the data. It's very brittle. So no separation concerns. That was the first thing that jumped out at me. So historical comparison. If you have gray hair like I do, you went through the pain we went through from client server, and then the web happened, and all of us Power Builder VB developers that had database skills went out there to build the next generation website, and it fell over very rapidly. When we figured out we could only scale to the maximum concurrent connections our database could hold. So middleware was born, where we had separation concerns, so 3-tiered, 3-layered, multi-layered architecture, which exists today, and most systems are built this way. There's sub-layers between them, but essentially we're in the same spot. So today, most blockchain apps are 2-tiered. You have a blockchain data tier, and then you have this wallet, right? What is a wallet? A wallet is essentially a place for you to store your private keys. So public-private key pair, your private key, and it derives other private keys from that wallet. If you lose your private key, you're done, right? You've been wholly compromised. If somebody gets your private key, they can take everything that you own. Anyway, can't do much with those 2-tiered systems, but here we are to talk about how we do 3-tiered architecture to really lead to the promise of what blockchain can do. So here, ta-da, finally getting to some architecture, and I'll get to some real demos here in a minute. So here's the current contract. So we're moving to this, it's 3-tiered. I'm not going to talk much about the user interface stuff because presentation tier doesn't change too much. So we put their data and the schema down there. So like store procedure code that you would do, your schema down at the bottom, and then put your business logic in a middle tier, which we call cryptlets. And we've changed the definition of a contract. So a contract isn't just the Solidity file. It's actually composed of these different things. So the ledger, the database itself, that's the actual instantiation of a version-specific contract between several parties. Now, the ledger itself is simply an instance of a template. Just like that loan form that your car salesman has a stack of them in the drawer and he just picks the top one out and fills it out. Smart contract ledgers are just like that. You pull a template, which is that schema. This is that Solidity code. You deploy it, creates your ledger. Then you have counterparties. Those are people that are signing on to this agreement to sell or buy or participate in some sort of swap. Oops. And then you have your logic, and then you have external sources as well. So that's what we call a contract binding, which is really a definition of a contract. So, Cryptlet Fabric. So this is our middle tier that can run in Azure Stack. Essentially, that it's very similar to app servers when you introduced database, app server, and then you had your front end, except there's a lot of differences here. But the concepts conceptually are the same. We have, at the bottom, we have the distributed database, right? So we have our data tier, we have this distributed database, a shared truth. In the middle tier, we have the cloud, which is also distributed worldwide. So we don't have speed of light issues, things like that. But we also need to have, remember, blockchains are multi-party. App servers, when you installed an app server, that was for your company. So when Facebook buys app servers, they put them in they're for Facebook. When you build blockchain apps, your middleware is for everybody that's on that network, or potentially everyone that you're going to be trading with. So the cloud is very good for doing that and building that out. So let's talk about what this does. There's 4 building blocks that we're combining here to create this platform called the Cryptlet Fabric. The first is the worldwide distributed network or the cloud. So Azure, great runtime. I already talked about that. That was sort of the first thing that popped out. Then the second is secure storage. So Azure Key Vault, which is HSM in the cloud. It's essentially a big wallet where we can store private keys. It's a bring your own key solution. We use the heck out of this thing because it is truly valuable for us here. The second is identity. Azure Active Directory, providing the capability to authenticate users into them. And then we have this new entry called enclaves. How many have heard of enclaves? Anybody heard of an enclave? Nobody? Really? Okay. So an enclave, anybody have a cell phone? Anybody have a cell phone? A smartphone? Okay. You have an enclave on your smartphone. It's called a secure element. It's when, if you do mobile payments, that's a secure element. NFC has a secure element. It's just a little piece of actually silicon that's isolated from everything else, and you can't get to it. And code and secrets can be in there, and it can't be tampered with. It can't be snooped upon. And anything that comes out of it, you know is authentic. It's been attested to. Well, we took that, Intel and other chip manufacturers, and taking that higher level. The first version that Intel came out with is called software guarded extensions, or SGX, which is in most of the new chips. And it has an enclave capability. So it's a piece of silicon that burned into the silicon is a key pair. So any code that runs in there, any secrets that run in there, the outputs from that are signed by that enclave and attested that that code ran as is, and the output is attested to. Now, why is that important? That means that you can take your code that you write and have it run on a completely infected public computer and know that your code will be fine. It can't be tampered with. So I bring that into the cloud, and we talk about that multi-party compute capability, and it starts to become interesting. So this confidential compute capability, where we're saying we're going to pull these hardware and software resources at a worldwide scale, so you can have on-demand creation of these secure secrets infrastructure, tie in identity and authentication and authorization, HSMs for storage and persistence of your key over time. And you combine these things together, and you get this really interesting scenario where in the enterprise specifically, we talk about identity. Most companies, they issue their users identities, get an email account. At the same time, they can be issuing you secrets or key pairs that work on blockchains that they're participating with. So you can have single sign-on for you to participate with blockchains, right? So we map the identity to secrets in the vault, and then we can use the enclaves to digitally sign on behalf of you or an IoT device or a company to allow you to transact securely on these networks. So cryptlets, what are they? They're little programs that represent two different categories. And you can write them in .NET, .NET Core, and JVM, or native. If you're still writing C++ or C, you can still do that. But the two categories that we have here, also the other runtimes, if customers demand or want some other ones, we'll put them out there. There's a lot of interest in functional languages as well here. Anyway, utility cryptlets. These are cryptlets that don't perform contract-specific execution. So remember I was talking about external data coming into your blockchains or blockchain oracles? These are utility cryptlets that are providing market data, for example, weather data, some sort of event. You can write your own if you have a ERP system that you want to have fire an event into your blockchain, or vice versa. You can write a utility cryptlet to be a bridge into the blockchain. So all sorts of things you can think of, you can write a utility cryptlet to do that. The second one is contract cryptlets. This is where we actually change the architecture. This is where you're pulling that logic out of the smart contract that's on the blockchain and putting it in this code that's running in a secure environment. So it gives you that attested execution logic. Both utility cryptlets and contract cryptlets have attestations using the same technology. It's just they're scaled differently. And we'll talk about the scale here in a minute. But you have true separation and concerns. You can do some very interesting things with advanced crypto. Let's talk about how these things work. So the first sort of use case that people come up with is blockchain oracles. So you can grab a create a utility cryptlet as a oracle and work with existing smart contract. So this is existing smart contract where we have the logic. So we have the blockchain node. The contract is, you can see that function there, that mathematical formula. That's actually a swap function, a financial swap, which takes some input to perform that calculation. So you can create a subscription to a pub-sub model where the smart contract subscribes to the cryptlet that's going to publish prices, attested prices to them based on some conditions. So it's just like any other event. You say, hey, at 4 o'clock, if the markets were open, give me the price of gold and the LIBOR rate. And that event fires, and then it provides that to you. Now, it provides it to the smart contract. The code still runs that formula on the node. It's just getting the dynamic variables to do the calculations. And see that little proof there? That's the attestation. These are digital signatures and proofs. I'll talk about those in a little bit. Then a contract cryptlet, this is where we say, okay, let's take that formula, and now you'll see that formula is moved up to the cryptlet, where the swap calculation is being done there. And we can just do that calculation and write directly to the database. And then lastly, we can combine them, or we have a contract cryptlet using a utility cryptlet to get its prices, and then persisting. So it asks for the price of gold and LIBOR. It gets those provided. It performs the calculations, does what it needs to do, and then persists the data to the blockchain with a proof chain. It's not just the proof from the contract cryptlet, but it also has the proof from the utility cryptlet, which is important when you start to think that companies will be executing contracts that run automatically and dynamically without any intervention on them, can move millions of dollars. They want to make sure that the data that is input to their function hasn't been tampered with. If you know anything about the LIBOR scandal, you know what I'm talking about. So underneath the covers, what's happening here, I'm going to try to get to a demo really quickly here. But where you're doing digital signatures, so you do a lot of signing. Every transaction is signed. We actually do lots and lots of signing. If you've ever done PKI and talk about certificate chains or proof chains, we have something I'll talk about called the signature onion. But same concept here. So we have the ability to mix and match elliptic curve cryptography and RSA. Most blockchains are using ECC, which is sort of novel, but it's heavily used there. We also have a piece of code that can sit on the node. So this is sort of a client that talks to the fabric or has a secure communication channel with the fabric called the crypto delegate. This is platform specific. Let's talk about real quick the cryptlet flow, what happens here. You'll actually see this in a moment. So as a developer, let's say I'm just want to use an Oracle cryptlet. I'm running my smart contract. I'm going to run all my logic in the smart contract, but I just need to get some market data so I can calculate it. So I'm going to go out and shop on the cryptlet registry and say, oh, there's a cryptlet that'll provide me the market price I'm using. So you'll make a reference to it, which essentially means it has a callback signature. So it's a callback function with a function signature that you'll put in your source code when it's deployed. And then you'll create a binding. So the binding is the relationship between the Oracle cryptlet and your smart contract, such that once you create a binding for that pricing information, no other entity can update that price function, just the utility cryptlet. So it can't be spoofed, and it creates that secure binding. So the framework checks and validates these bindings. When a binding becomes active, cryptlets boot inside what we call a cryptlet container that does a lot of the key exchange for you automatically. Your cryptlet will run, create its payload in a secure environment. When it's done executing, its payload gets signed by the cryptlet. So the cryptlet has its own key pair. It signs it. It will pass it to the cryptlet container, which will then have the enclave sign it. So the enclave signs your signed payload. So we have our core data. We have one envelope, or I call it the layer of the onion, one onion layer. Then the next layer of the onion is the enclave. Then we have a transaction builder, which actually provides the blockchain-specific transaction formatting. And then it gets signed by the blockchain-specific key, which is another layer. And that also is running in an enclave, so it could have an additional layer itself. Then it finally gets delivered. If there's a crypto delegate on the other end, the crypto delegate's primary purpose is to validate the layers of the onion to ensure that the data that's coming into the blockchain is valid and authentic, not being spoofed. Finally gets delivered to the smart contract and gets persisted. This is what the crypto onion layer looks like. It's this layer of attestations or proofs. Now you can configure this to do as few or as many layers as you want in your system. Some advanced topics that we'll talk about briefly. Most contract cryptlets that are run in serial, meaning it's a workflow-based kind of cryptlet where one party comes in and does something. The next party can't do the next step until the first party does the next thing, so it's done in serial. Then we can run a singleton and just marshal in keys in and out based on who the counterparty is executing the logic. If, however, you're running in parallel, we can run them in pairs. If it's two counterparties, if it's more than two counterparties, we can run them in rings. And each one can hold its own secrets. So each one can run the same code with a different set of shared secrets. They can also share secrets between themselves and create these little dark networks to do things like ring signatures or threshold encryption. If you don't know what those are, don't worry about it. But if you do know what those are hard to do and do in a costly manner. So we bring all this together, and here's this eye chart of what the cryptlet fabric kind of looks like. So down at the bottom, we have our data tier. That's where we have blockchain agnostic. So like if you build enterprise systems or a three-tiered architecture, you can say, oh, I can work against SQL Server, I can work against Oracle, I can work with Sybase, whatever you have. It should be the same thing here. As you build your blockchain apps, should be portable across them. We're not there yet, but that's the goal is to have this abstraction layer so you can take and move your apps across. Your cryptlets themselves, you write in either a .NET-based platform, Java. Others will come based on demand as well. And then up above, you have these interfaces that you want to work with. So let's see this in action. So I'm going to show you contract as a service, which is taking the cryptlet fabric and making it as productive as possible. Now, I would never show this demo to non-technical people because it's not very pretty. But what we have here is I'm connected to a node on an Ethereum network. And you can see, hopefully it hasn't timed out on me. Yeah, there's transactions that are posting there. It's not doing much at the moment. What I'm going to do first is I'm going to boot up a local cryptlet fabric. And you'll see it's some of these. You wouldn't normally see these, but for developer audience, I let you see the terminals. So this guy is booting up. We have lots of keys being created and fetched, secrets from the key vault being securely brought into enclaves. And then we can start to see some messages come in. So this guy actually has a subscription already, and it is publishing. Let's see what it's publishing. It's publishing the price of gold every 10 seconds. This guy's going to be kind of busy. So you'll start to see these transactions come in. And somebody's not happy. Oh, here we go. That was the problem. I think I hit enter on one of these guys. Because my messages are not going. It wouldn't be a real demo if it didn't blow up on me. Let me reboot this guy and not touch my mouse. Okay, so he's starting up. Now, what I can also do is I'm going to start up this little watcher here, and I'm going to see, now you're starting to see transactions come pouring in. There's probably a bunch that are queued up. So these transactions, yeah, they're coming in pretty quick now on the blockchain are flying in. Those are just Oracle prices being pumped in by the Oracle Cryptlets. Now, what I'm going to do is I'm going to show you how, let's see if I can get the, some folders up here. I'm just going to show the messaging. So what I've got here is a Azure Service Bus. So I'm using messaging as an API instead of RPC to send and receive messages. So the first thing I want to do is I want to, I've never worked against this Cryptlet fabric before. I want to find out what's available to me. So I'm going to drag and drop the get catalog message, which essentially looks like this. It's blank. And give me what you know, and it responds back with everything that it has in here. And we're just passing around JSON here. So I can see I've got Cryptlet packages. I have this simple asset Oracle that I can use. I have this function Cryptlet, so we can use write Cryptlets and use Azure functions for rapid application development. And then I have this thing called a swap, this total return swap, which I'm going to take a look at. So I can come in here, and I want to create this swap. So I'm going to just drag and drop this swap over here. And what this is doing behind the scenes is it's actually creating my schema for me. You see this created right here. That's the transaction that actually created the database for me, or the smart contract on the ledger. And it's creating a binding between, the contract Cryptlet actually created its own schema. So that message got routed to the contract Cryptlet. It says, hey, create a new contract. It goes and persists and creates a contract, wires up the binding automatically. So it's automatically created a secure link between itself and the blockchain. And then I can begin running with it. And it should have come back with a deployment bundle. So this deployment bundle has a set of information. So it tells me, what the block hash was, what block number it was created in. But what I'm most interested in is this binding ID. So this binding ID uniquely represents my contract. So that the contract in this case is the Cryptlet, and it is also the smart contract itself. And what I'm going to do now is I'm going to get rid of this guy. I copied this guy, and I want to get the swap detail. So I'm going to paste that binding ID in here. Oops, I don't want the created part. Save this guy. And now I'm going to just drop this in there and say, hey, give me the swap detail. So I'm just sending these messages in as an API. And it's just going out and getting me the swap detail. And I think I messed that guy up when I edited it. My mouse is really screwed up here. Delete that message. I can also do things like create a new Oracle. So I can create this new Oracle out there, and it'll eventually pick that guy up today. And then lastly, you could also wire this guy up to a regular user interface. So just using that messaging-based interface, this is a regular Windows format, but I can go in and take a look at the different bindings. Here's this total return swap that I created. Here's that binding that I have here. Here's this existing Oracle that's getting the price of gold every 10 minutes. I can do things like change the cipher if I want to go from elliptic curve to RSA. I can query the blockchain. I can take a look at those same, this is not a really good user interface. I'm sorry, I'm not a good designer. But I can pick any one of these guys and say, I want to deploy one of these packages, and walk it through a little wizard and fill out my wizard, and it'll go out and deploy that smart contract to the blockchain. You'll see this. It created it, and it'll come back with a fancy-smancy transparency to show me that I was successful. So with the contract as a service, you'll be able to just work with JSON messages, send them. In this case, I'm just using the service bus. Pop them on the service bus and interact with regular messages. And you can build user interfaces. You can do binding with those. And it is fully discoverable. So you can just, again, say, hey, give me the catalog. Each package, you can then query the package, and you'll get the entire message API for that cryptlet, that contract cryptlet that's there. So you'll be able to do complete interactions with it, which is a vast improvement over what's in market today. So let me go back to my slides. And say, this is essentially what you'll have. So to build this app, you have the fabric, which is just this runtime that you're going to write this thing in. So you're going to go out and you're going to write some code. You're going to go into Visual Studio and you're going to say, I'm going to create a new contract cryptlet. You inherit from a base class. You implement an interface and wire your stuff up, create your message types, and compile it into a DLL. Then you just grab that DLL and you drag and drop it, in this case. And as a developer experience, you'll drag and drop it to a folder. The Cryptlet Fabric will inspect it, pull out the API, and publish your messages at the surface level as well. You can also easily spin up regular API using RPC, REST, whatever you want to do. But the contract as a service will allow you to just drag and drop these, auto-publish your message types, and begin listening and routing them to them. Because we're using the service bus, you can also authenticate to the service bus and pass those authentication tokens in. We're producing an end-to-end scenario demo that you'll be able to get the source code for this. It's actually the swap scenario I was showing you, where you'll be able to do the Contoso blockchain app and inspect exactly how we did this. So you'll have the Solidity code at the bottom. You'll have the contract cryptlet code. You'll have a utility cryptlet to get volatile data from, and the surface level API, and then we'll have a really nice and pretty user interface on top of it as well. So the design here is to make you as productive as possible. Has anybody ever done a blockchain hackathon? Anybody? Nobody's done this. So a lot of hackathons they'll do over a weekend, and the early hackathons, by the end of like Sunday, if you actually had your network stood up, you're doing good. The ones that we were doing 2 weeks or a month ago, people were still struggling they weren't even getting user interfaces spun up. They were just getting their basic networks. So we did a basic proof of concept with a customer and a partner, where we had them do side-by-side comparisons with a smart contract getting an Oracle pricing, just writing all your logic in Solidity, which is terrible to debug. You can't figure out what's going on. It's hard to write in. And then we had this team in the same company use that same Oracle cryptlet that was getting the pricing information, but they used a contract cryptlet. They wrote their contract cryptlet in no time, and then they spent all their time creating user interface. And the judges were the lines of business executives. And I can tell you, I don't care how elegant the other team's code may have been, it was the user interface that won over the business people. So this makes you much more productive in a lot shorter period of time, but lets you do things in an architecturally pure way, if you will. So next steps, things that you can do. We do have landing site on Microsoft and Azure.com. There's a GitHub repo with our projects. You'll be able to see the deployment templates out there for both dev test labs. We have lots of people that go out, and you can just grab these templates. One of the interesting things that you can do in the existing blockchain as a service offerings, you can grab any one of those templates that are wizards, and at the end of it, you can just save out the JSON script and use it as a template yourself. So we do have additional sessions. This session is actually recorded. And thank you. Please fill out your surveys and enjoy the rest of the show.